Hi, welcome to Dr. Raz, the Baking Chemist. So today is all about free radical substitution. It's one of the mechanisms that year 1s need to know, year 12s, but also year 13s or year 2s. Let's do this. Okay, so the question says, it's a long question, it's a 9-marker question. Okay, so it's total 9 marks. Let's just make a start with this. All right, haloalkanes are used as refrigerants, solvents, and anesthetics. So some background information. Trichloromethane is a haloalkane that can be formed by heating a mixture of chloromethane and chlorine. So that's what they're forming. Write an overall equation for the formation of trichloromethane. So formation of trichloromethane by the reaction of chloromethane with chlorine. Okay, so the first question is simple really. So it will be chloromethane. They've even given you the formula in the question. So it will be CH, oops, sorry, let me just start it up again. So CH3 chloromethane, so chloromethane plus chlorine. And again, I'll come to the mistakes later on, what the students often do, or sometimes do actually. And then that forms trichloromethane. And they've even given you the formula of that, how kind they are. And then all you got to make sure is just balanced, isn't it? 2 chlorines, 3 chlorines in here, 3 chlorines here, just 1 hydrogen there, and there's 3 hydrogens. So there's obviously something going on. Yeah. Now immediately, what students might say, well, all right, there's hydrogen. There's 2 hydrogens more here compared to here, so it's just H2, just hydrogens. Yeah, you don't get hydrogen. Okay. What you get is HCl, so hydrogen chloride. All right, that obviously you need to know. Okay, comes from practice. You don't, whenever you react chlorine with chloromethane, you actually don't get hydrogen gas bubbling away. So obviously now you've got to balance it. So balancing it, the way I do it is I'd say that, well, there's 3 hydrogens here. There's only 2 hydrogens here. So if I put 2 here, that'll give me 2 hydrogens here, and that means there's total 3. But that's changed the number of chlorines. So 2 plus 3 is 5. And that's, yeah, so if I put 2 here, 4 plus 1 is 5. And I think that's balanced now, isn't it? Okay, so that's a 1 marker, believe it or not. All right, but students make mistakes here. Okay, so they might just put hydrogen rather than that. Move on to the next question. Name the mechanism for this formation of trichloromethane. Okay, well, look, even if you don't know, I mean, sometimes it's worth reading or glancing at the question ahead, because that sometimes gives you an idea. Name the mechanism, even if you didn't know what the mechanism is. Initiation, propagation, termination. Yeah, free radical substitution. So even if you didn't know, I just put free radical substitution. Okay, and of course, the mechanism is free radical substitution. Just making sure everything is recording properly. Free radical substitution. However, you can sort of forget, if you don't put free, my suggestion is always do that. Yeah, free radical substitution. That's the name of the mechanism. That's how I remember it. But if sometimes students don't write free, they just write radical substitution, they will get a mark. If you omit that and you just write substitution, you won't get a mark. Okay. So anyway, and I think with this question, I am going to go through mistakes as I go on, because there are a lot of places that students can make mistakes, and I might forget by the end of this tutorial, I might forget to mention some of them. So I am going to mention mistakes as I go along. So okay, so make sure it's free radical substitution. Oh, and don't write FRS, because that's how I remember it, but I will never write FRS by itself in the exam, because what does the examiner know what I mean by FRS? Okay, so don't just write that, please. Yeah, just free radical substitution. Okay, that's the 2nd mark done. 3rd, dichloromethane is an intermediate in this formation of trichloromethane. So now this is dichloromethane. Okay, now that's completely different to what they mentioned before. Is an intermediate in the formation of trichloromethane. So when they're making the trichloromethane, you get that in between. Write an equation for each of the following steps in the mechanism for the reaction of dichloromethane with chlorine, not chloromethane with chlorine, because students might think automatically, well, it's the same as that. Yeah, so they might start using chloromethane, but it's dichloromethane with chlorine. Anyway, the 3 steps with free radical substitution is always initiation, propagation, termination. 3 separate steps. Okay, initiation always happens with halogen or a molecule that contains halogen. In this case, it's chlorine. So initiation step will always be, in this case anyway, with chlorine. And what happens is UV light fired on the chlorine, and you get two free radicals of chlorine dot. There's your initiation step done. Okay. Second, now, once the initiation step has happened, the next one is propagation. Sometimes they can ask you just write one propagation step. Sometimes they can ask you to write 2 propagation steps. So you need to be familiar with being able to write both types of, both steps, propagation steps. First propagation step, all right, well, obviously I'm going to need that chlorine. So let's just write propagation step. Okay, and so it's obviously going to be that free radical that you've just formed with what? In the question it says with reaction of dichloromethane. So I might as well now react with dichloromethane. Okay, now, yeah, they've given you formula in there as well, so you don't need to worry about that. Now, remember, here, a propagation step, you have to have a neutral product and a free radical. Okay, so I'm going to have a free radical, which is going to be my free radical. I think I'm going to have, because they're asking for a second propagation step, okay, I'm going to have my free radical step, my free radical compound as, or molecule as, that. And then, oh, sorry, I made a mistake here, so it should be, oops, that, and then just, yeah. So CHCl, because what's going to happen is one of the hydrogens here is going to react with that to give you HCl. So that would be my neutral molecule. Can you see? If I, like I was about to do, if I had taken off the chlorine here, that chlorine would have reacted with this chlorine to give me back the chlorine again. Well, pointless, isn't it? Yeah, that's not what I want. I want to continue. So what's the point of giving me that and then giving me back to the original molecule? Yeah, so that's why. It wouldn't have been wrong, okay? In this question it would have been wrong, but in reality that could have happened, okay? Because remember, these free radical, this free radical substitution, we seem to think, oh, this happens and this happens and this happens, but in reality this is all random. Yeah, all these things, they can react with each other. I mean, in reality, these two free radicals might react with each other to give you back again. Yeah, so remember, free radical substitution is a complete sort of random events, yeah, where free radicals might, they will react with the first thing that comes in their way. Okay, however, in this question they're forcing me along a certain path. Okay, and that path is this. So anyway, that's the first propagation step. So chlorine, free radical, reacting with dichloromethane to give you a sort of dichloromethane free radical and a HCl. It's a propagation step because you get a free radical and a neutral molecule. Now the second propagation step is then you react with that CHCl2 free radical, and I'll tell you what the mistakes some students make here as well. And then of course now this question now would be, well, what do they now react with? What does this free radical now react with? Well, look, again, as I say, it could react with anything, so it could actually react with itself. So remember, I can probably get lots of these, isn't it? Yeah, so it can react with another of this free radical to give you a neutral molecule, but I want a propagation step because I want to make a free radical and a neutral molecule. So I guess if it reacts with another free radical, it's bound to just give me a neutral molecule. So this free radical now has to react with a neutral molecule. Okay, you can react with a number of, so you can react with that again, pointless. You might as well just react with chlorine to give you, so look what's happening now, to give you, remember what you're forming, this intermediate, what you're trying to form, you're trying to form trichloromethane. Okay, so look what happens now. I'm actually getting my trichloromethane there. Yes, if this reacts with chlorine, I can get my trichloromethane. So in this reaction, I'm getting my trichloromethane, look. Okay, and of course, propagation step, so I need a free radical. So if one of the chlorines is bonded to that to give me trichloromethane, what's left? Well, what's left is a chlorine free radical. Yeah, so again, it's a propagation step. I think it's the second propagation step that students find difficult, okay, because often what they will do is they will react this with another of this, or they might react this with that, and then they end up saying, well, okay, what am I getting? Think about what the question is. Question is forming trichloromethane, yeah, So this is a process of making trichloromethane. So here you're going to get a trichloromethane. And now, especially when you look at the termination step, yeah, I've seen it before, I should have pointed it out. Look at the termination step. Termination step leading to the formation of a compound with a formula. So even the termination step is not asking you to make trichloromethane. They're asking you to make something completely different. Yeah, so I can't say, well, I'm not going to form trichloromethane in this step, I'll make in the termination, because they don't want you to make trichloromethane in the termination step. They want you to make this something odd, yeah, something different in the termination step. So I've made trichloromethane here in my second propagation step. Okay, so now this weird thing molecule here, what is that? Okay, well, immediately, and this comes through practice, okay, I can already tell that this formula here is double that. Yeah, so it's like this twice. Yeah, so C2H2Cl4. Can you see? So what's probably happened in my termination step is these two free radicals, okay, they've actually reacted together to give you C2H2Cl4. Neutral molecule, okay, dots, neutral molecule. Okay, so this is a termination step. There is no free radical. Okay, so a couple of other places where they make a mistake is dots. Okay, you know, here it doesn't really matter where you put the dots in this kind of molecule. Here it doesn't matter, you put it here, here, you can put it here, here. However, if you start showing displayed formula, so if you start drawing this out molecule, then the dot has to be on the carbon. But in this case, it doesn't really matter. Dots here, 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 it doesn't really matter. Okay, but remember, the free radical is usually always on the carbon. Okay, whenever you're talking about hydromolecules, hydrocarbons. All right, so that's that question done. So that's 4 marks done. Now B, okay, trichloromethane, so yet a different molecule, is used as a refrigerant, but is being phased out due to concerns about ozone depletion in the upper atmosphere. In the upper atmosphere, so can you see a bit of background information? They're already taking you along that line. It's to do with upper atmosphere, it's to do with the ozone. In the upper atmosphere, CClF3, so chlorotrifluoromethane, decomposes in the presence of UV light, forming a reactive intermediate that catalyzes the decomposition of ozone. Yeah, so it decomposes ozone, yeah, forming a reactive intermediate. All right, and it's that, isn't it, right? Write an equation to show how CClF3 decomposes to form the reactive intermediate. Now, whenever you have a chlorofluorocarbon, CClF3, the free radical formed is always chlorine. Okay, so it's the CCl bond that breaks. So here, and I'm going to draw this out for you just to show you, this molecule, this one here, looks like that. So it's got 3 Fs and 1 Cl. Now, when UV light, shines on it, or when it gets up to the atmosphere and it's exposed to UV light, the bond that breaks isn't CF, it's actually CCl. Okay, so what the free radical that you get, so you get this and this. Okay, now what usually happens, the reactive intermediate that reacts, okay, this is reactive as well, but this is the one that causes problems. Yeah, the chlorine free radical, any free radical causes problems, but this is the one that really causes problems, as you'll see in the next part of that question. Okay, but anyway, there's the equation. I know I've drawn a displayed formula here, but it doesn't really matter. You could have done a molecular formula here. Okay, so that's that question done there. Okay, and that's the reactive intermediate. Right, write 2 equations to show how this reactive intermediate is involved in catalyzing the decomposition of ozone. 2 equations. People, these 2 equations, memorize. Okay, they're in your textbooks, they're on the internet. These 2 equations, just memorize. Okay, and actually, if I turn over, yeah, so it just says 1 and 2, and it's still at 2 marks. Just making sure it's there. Right, so the 2 equations, obviously you're starting, so here's my equation number 1. You're obviously starting with a free radical chlorine. And what is it? Decomposing ozone, right? So of course it's got to react with ozone. And of course it's not O2, it's O3, ozone. All right, and then what happens, and the way I remember it, both of these equations involve ozone as one of the reactants. is the way I remember it. And both of these equations give you oxygen. So I know you get oxygen here. Well, then you think, okay, well, O2 is there, so 2 oxygens are gone. How many left? Only 1. So that must react with Cl dot to give you a free radical. Yeah, and again, that dot could be here or there, it doesn't really matter. Okay, and of course, remember, both reactions involve reactions with ozone. All right, but remember, these two reactions, so this reaction follows that. Yeah, they are related. So of course, in the first reaction, the only free radical that I get which can react is that. So it must be that free radical reacting with ozone to give you, and this is slightly different. I did say they both give you oxygen, and that's true. Okay, but here you need to remember that you actually get 3 oxygens here, 3 O2. Yeah, and also, and remember, this is a catalyst. So in the second, my final reaction, this must be reformed, this free radical, to be able to continue to react. Yeah, so I get that free radical. Okay, and of course, this is not balanced yet, so I now need to balance it. So, oh no, okay, so that's not, sorry, that's not 3, that's 2. So that's 4, and there's 4. Yeah, so 3 plus 1, 4 oxygens, and chlorine free radical again. Sometimes they do, this question isn't, but sometimes they do ask you to write an overall equation, and all you then do, okay, but in this question they don't. Yeah, in this question they just want those two, right? But if they do ask you to write an overall equation, then all you do is just add them together, add these two together, right? So Cl, so anything that's on both sides, so look, that Cl dot, okay, let's just do it. Okay, so there's my arrow. I'm going to add all of that together. Cl dot plus O3 and plus O3, I might as well put them together, plus O dot, sorry, dot OCl. And on this side, dot OCl plus O2 and 2 O2s, so I might as well put those together, and then plus dot Cl. And of course, anything that's on both sides I cancel. So dot Cl cancels, dot Cl cancels, OCl cancels, OCl cancels, and all you're really left with 2 O3s. So the overall equation is 2 O3s goes to 3 O2s. And in other words, 2 ozone molecules are becoming 3 oxygen molecules. Now you might think, oh well, we'll get more oxygen. But that's another question, right? We're getting more oxygen. It's fair enough. We all need oxygen. We also need ozone, because ozone protects us from UV, which protects cancers, blah, 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 etc. That's another question. Okay. Anyway, this question is all only up to here. One or two other problems that students do is they start putting charges for some reason. Yeah, minus or plus or whatever. Every time you do that, you are going to lose a mark. Okay. Another mistake that they do is they forget to put dots. Or they write dots so small, the examiner can't tell whether that's a dot or not. And of course, anytime you miss a dot, you will get penalized. You'll only get penalized once if you start missing a dot. So let's say you've forgotten that it's a free radical that contains a dot, so you miss a dot every time. All right, you'll just get penalized once. But if you start writing charges, you get penalized every time. Okay, so that is worth 9 marks. Okay, so 1 there, 1 there. I think this is worth, yeah, each equation is worth 1. Okay, and this one is, yeah, another mark. So it's quite simple, really. Each equation equals a mark. Okay, look, this question you must practice, especially these 2 propagation steps. Right? How do you know which molecules you need to use to do first propagation step and then the second propagation step? Which free radical you get, which neutral molecule you get. I think this is where students get confused. Yeah, and often they can't write 2 propagation steps. My suggestion is either do this question yourself, yeah, or better still, find another question like this on the internet and try it yourself. Yeah, get used to it, because you don't want to get bogged down with trying to remember, oh my god, which is the second propagation step. Yeah, you just want to get on with more difficult questions in the exam paper. All right, so as I say, this is a year 1 question. You should have done it in year 1 or year 12, but again, year 13 or year 2 will also need this. Okay, along with some other mechanisms, which I'm sure I'll go through in one of the other tutorials. Okay, well, I hope that was useful. Have a look at some of my other videos. If you do have any other sort of request that you want me to go over, any particular questions, please let me know. and I'll make sure I go over them. All right. Okay, thank you. I'll see you next Tuesday. Bye.